Hello, in this video, I will explain to you on how to solve the problem. However, I changed the subject a bit here because we all know that stop the train is Spider-Man, not Superman, right? So, the question is Spider-Man must stop a 120 km per hour train in 150 meter to keep it from hitting a stalled car on the tracks. If the train's mass is 3.6 times 10 to the 5 kilogram, how much force he must exert? Okay, let's see here. Let's see here, we have the mass of the train. That will be 3.6 and then multiplied by 10 to the 5 kilogram. Good. And then the initial velocity of the train, that will be VO. And that will be 120 km per hour. However, we need to convert this into SI unit to get easy to work with, right? So let's convert this into SI unit. So 120 km is 1200 meters. Or no? I think I need one more zero, right? 120,000 meter. And then we need to convert the hour into seconds, and 1 hour is 60 minutes, and 60 minutes is 60 seconds. So I'll have 60 times 60, we will have 3600 of second. And I think we need to do it by calculator here. So I have 120,000 divided by 3600. And that will be 33.33. Okay, so I have 33.33 and the unit here will be in meter over second. And then we need to get the train stop. So I will have our final velocity, Vt here is 0 meter over second. Good. And the question is the force. The force, so we will have sigma F is equal to the mass times the acceleration. Okay, but then we need to find out the acceleration first. Okay, what else that we are given in the problem? We are given that is 150. So I will have that s here, the distance, that will be 150 meter. Okay, and to find out this acceleration, we need to use the kinematics formula. So the first step that we need to do is to find the acceleration or deceleration if you wish. So we will have the negative sign here. So remember, from the kinematics, we will have Vt squared is equal to Po squared and then plus 2 multiplied by the acceleration time distance. Good. Now what is Vt squared? I will have 0. And then what is Po squared? I will have 33.33. Good. And that will be squared. And then we will have 2 multiplied by unknown A. But then S is 150. 150. And this one will be A. Good. Let's move. I think we can isolate A here, right? So maybe let's work it here. So we will have 300A, right, from this term. And let's move this to the left-hand side. So we'll have minus 33.33. And this one will be squared. Or we can get the A here. So I have minus 33.33 square divided by 300, and that will be our acceleration or deceleration because we have negative sign. Okay, let's do that using calculator. So we will have minus, and then we will have 33.33, and that will be squared, and then we will have 300 on the denominator. Okay, so I will have minus 3.7 minus 3.7 meter over second square. Okay, so this is one of the most important values here. Let's clean up our slide and work on the force that he must exert here by Spider-Man. Okay, now that we have the mass and acceleration, we can calculate the net force. Okay, and that is our second step, calculate the net force. And so let's get back to this formula here because we already get the A, right? Good. What is our M? So we will have 3.6 and then multiplied by 10 to the 5 and then multiplied by minus 3.7. Okay, and then that will be minus, right? So we'll have minus. We will have 3.6 multiplied by 10 to the 5, then multiplied by minus 3.7. Okay, and we will have this one here, minus 1.332. Okay, minus 1.332. But then that will be multiplied by 1, 2, 3, 4, 5, 6. I will have multiplied by 10 to the 6. And the unit here will be in Newton. Okay? And that is the net force that is needed to stop the train. And then we have also to compare the percentage here. Let's do that. So we will have the step number 3, percentage. How to do that? We can just divide this here. So we will have minus. I think the sign does not matter here. So we will have 1.332 times 10 to the 6 divided by, okay, compared to the weight of the train, we will have this mass here, 3.6 times 10 to the 5, but this is the mass of the train. We still need to multiply it by the gravitational acceleration, which is 9.8, and then multiplied it by 100%. And that will be, I think this one will be the job of our calculator. Okay, so I'll have 1.332 times 10 to the 6. And then we will have 3.6 times 10 to the 5. And then multiplied by 9.8 here. And then multiplied by 100%. Okay, so we will have 37.76. 37.76. And the unit here will be in percent, right? And that is the answer for this question, 37.76%, and the net force is this one here, minus 1.332 times 10 to the 6 Newton. Okay, and I think that's all for this problem. Thank you for watching. See you in the next video. Bye bye.